start, and please start by answering the question that you have, and it would be nice to know from where you are at in the world. And I will try to do the same while speaking. Okay, that's me. So we are two then. Hopefully there will be a few more soon. Let's do like this. Please answer, and we can open it up later when we have more, or maybe let's keep it and I will start speaking instead. Okay, everyone. Hello and good morning from Sweden, from the Swedish West Coast. My name is Malin Lundberg Ingemarsson. I am program manager at SIWI Swedish Waterhouse, and I am also the chief editor of the report on climate and climate mitigation and freshwater that we are building this webinar series on. Over the coming months, we will deep dive into 5 of the chapters in the report. And soon you will see the list of webinars. Yes, thanks, Malin. So this first one, it's on climate mitigation in drinking water and sanitation services. And it will be followed by webinars on energy systems, freshwater ecosystems, land systems, and one on integrated approaches. And before we go into the, let's see, next slide, please, Malin. Yes, exactly. Before we go into the report, I would like to, or before we go into this chapter, I would like to give an introduction to the rest of the report. And please note that it's possible to post questions in the chat throughout the session. And there will be a Q&A session later, so then we will attend as many of those questions as possible. Next slide, please. So this is the report with a long name, The Essential Drop to Reach Net Zero, Unpacking Freshwater's Role in Climate Change Mitigation. It was launched at the Climate COP last year, and it is a joint effort by SIWI together with Stockholm Resilience Center, Potsdam Institute for Climate Impact Research, the UN Development Programme, UNDP, GIZ, the German Development Agency, and also the German Federal Ministry of Economic Cooperation and Development, called the BMZ. Next slide, please. Yes, in the report, we have mapped climate mitigation measures, and we can call them climate actions or climate response options. And we have mapped these measures by looking at the mitigation potential of the measure, but also the freshwater dependence or the freshwater impact. And we have focused on both natural ecosystem measures in natural ecosystems, but also in technological systems. And the technological systems, they include energy, as well as drinking water and sanitation services. Then we have freshwater ecosystems, which includes rivers, lakes, wetlands, as well as coastal systems. And the land systems, that includes forests and forestry, croplands, and rangelands. But one also important part of the report is that we identify freshwater-related synergies and trade-offs that exist between climate mitigation and climate adaptation measures. We also identify synergies and trade-offs to enhanced system resilience, functioning ecosystems, enhanced biodiversity, as well as contributions to sustainable development. Next slide, please. Yes, so with that, I hand over to two of the chapter authors. It's my colleague at CIWI, Ricard Ginet, and it is Jacek Makinia from Gdansk University of Technology. Welcome both.
Thank you. Thank you. Go ahead, my applause.
No, please go ahead.
Okay, yeah, thanks, Malin, for this introduction. And yeah, it's great to be here today in this webinar. Basically, the idea of this presentation, as Malin has suggested, is to show that the drinking water and sanitation sector is indeed a major contributor to climate change mitigation. So basically, in the next slide, what we can see is that there are two key pathways where wash services contribute or can contribute to climate mitigation. There is first direct emissions that are mainly produced during wastewater treatment and sludge disposal. And basically here, there is a need to highlight the role of emissions related to methane and nitrous oxide. But there are always indirect emissions that are associated with energy and material consumption that is consumed during the delivery of drinking water services and also during the treatment and collection and transport of wastewater and fecal sludge. So basically here we need to focus on the energy that is consumed during these processes, but also related to transport and chemicals that are needed to treat and produce drinking water and also to treat and dispose wastewater and fecal sludge. So in the next slide, what we can see is some big data related to how the waste sector and waste services are contributing to these greenhouse gases emissions. We can see, and there is kind of uncertainty in relation to the data, that wastewater treatment today produces around 1 to 3% of total greenhouse gases emissions. And particularly with a focus on methane and nitrous oxide, we can see that the proportion of these two gases is around 12 and 5% respectively. We can also see that there is a huge impact when it comes to decentralized sanitation. Here again, there is big uncertainty in relation to the data, but it's important to note that these sanitation solutions are the ones that are being used by more than 1.6 billion of people in the planet today. And finally, there is also a big contribution and direct contribution when it comes to the production of drinking water and wastewater management. We can see, for instance, that this sector is responsible of 4% of total global electricity consumption. And this is going to increase in the next years and is expected to reach the 50% of the total energy consumption. So the chapter, and in the next slide, we can see that tries to present some solutions that could be implemented to address and to sort out this kind of direct and indirect greenhouse gases. For direct, we can see that the best option is to try to minimize by modifying and controlling the operational units of existing wastewater treatment plants. This is not always possible, so then another option is to apply new treatment configurations, particularly when it comes to the anaerobic digestion of the wastewater. There is also the possibility to capture biogas and valorize this biogas. This also applies, for instance, at the household level with household digesters. And finally, there is also the possibility to improve the design of decentralized sanitation solutions. As I said, the impact here could be huge due to mainly the number of people that is today accessing these sanitation solutions. As regards the indirect contribution, there is the possibility first to understand what's going on in our process by conducting energy audits and also try to cover the whole life cycle assessment. One major contributor in terms of energy consumption is the aeration units of the wastewater treatment plants. So that could be something that could be easily addressed. There is also the possibility to enhance pumping operations. There is also the capacity to reduce non-revenue water and all the associated energy consumption. And then, of course, there is also the possibility to use more renewable energy. Finally, we are now moving and transitioning to a new area of wastewater treatment plants where we can achieve energy neutrality. And I'll give now the floor to Jacek because he can explore in more depth this opportunity. So over to you, Jacek.
Thank you, Richard. Hello, everyone. Yes, I'm a sanitary engineer, so I would like to say a few words about sanitation systems from the engineering perspective. And I would like to start with the current situation, the current model, urban water system, when we have water withdrawn, delivered to citizens, and then collected, treated, and discharged to receiving water bodies. So this linear system has worked perfectly for 100 years, but from today's perspective, it is inefficient. It's not a sustainable solution because of the inefficient use of resources and high energy consumption. So we would like to, and we should look for a new model, which is called the forced water revolution. And I would like to give you a picture. In the United States, water and wastewater treatment facilities emit CO2 in the amount equivalent to 9 million cars. So next slide, please. So we come now to the new paradigm of wastewater treatment, when we treat wastewater not only as a threat, but also as a resource. And we should focus not only on removal of pollutants, but also on resource recovery. And then it comes with energy consumption, use of chemicals, greenhouse gas emissions. So those actions for climate change mitigation, and using carbon footprint and life cycle assessment, we can evaluate the effect of wastewater treatment facilities on the whole environment. Next slide. So in terms of greenhouse gas emissions, those indirect emissions, scope 2, energy consumption in wastewater treatment plants, and scope 3, transport and chemicals use, are pretty well defined in wastewater treatment plants. In contrast to scope 1, direct emissions, especially N2O, nitrous oxide, which has a high global warming potential. And I would like to show you this on one example. Next slide, please. Yes, this is one of earlier studies on greenhouse gas emissions in wastewater treatment plants. So as you can see, in terms of tons per year, N2O is very low in comparison to carbon dioxide. It is more or less 20 times less than the emission of CO2. But in terms of in terms of CO2 equivalence, which takes into consideration the global warming potential, the emission of N2O becomes 15 times higher than CO2. So it comes to 85%. The share comes to 85% of N2O compared to only 5% of CO2 and 9% methane. Yes, please, next slide. So the problem is that we suffer with lack of data for emissions of greenhouse gases. And we, at this moment, basically we use empirical or fixed emission factors with the value of 1.6% of the total influent total nitrogen, which is the recommended value. And there are very few field measurements of greenhouse gas emissions directly in wastewater treatment plants. So in one study performed by our group, we compared this empirical factor with the actual emission. So it turned out that there was a big difference. So according to our studies, this emission was below 1% of the total influent nitrogen. which comes to the to the big difference in the CO2 equivalence, about 1,000 tons in a facility, in a large facility of 200,000 population equivalents. And it also shows the importance of the full-scale measurements and model applications. Yes, next slide, please.
Just a heads up that your time is up. So I know you have 2 more slides. So
yes, this is my last slide. So I would like to show that this is our goal. Wastewater treatment plant of the future, with the 4 goals actually: high water quality, resource recovery, and also energy neutrality and low carbon footprint. Yes, please next slide, and I just hand over to Ricard.
So yeah, in 30 seconds, Malin, and in the interest of time,
no stress. We will have time. Please go ahead.
Okay. No, just to say that I think that the challenges have been already highlighted. We lack data, we need more evidence, and I think that this is something that the sector is trying to move on. And this will be presented in more detail by David. There is poor representation of the waste sector in climate policies. I mean, I think that there is progress here, but more needs to be done. And particularly from the waste sector, we need to include this climate lens also in waste sector policies and strategies. And we need to estimate better what are the contribution of the waste sector in terms of climate mitigation, in order also to improve our potential in relation to climate finance. And the way forward, and it's going to be discussed later in the case studies, we need, of course, to increase the evidence. We need to enhance policy making. We need to make sure that all this evidence are part of these policies and strategies in the sector. We need to incentivize investment, and I would like here to focus on focus the attention on the need to align this new investment and climate finance to the critical needs, making sure that those that still today do not have access to water and sanitation services do have proper solutions. So this kind of climate justice and human rights to water and sanitation emerges as a win-win solution. And finally, we need to gather the momentum. I think that we are moving forward. We are making it every day better and better, but more needs to be done. And of course, there's an opportunity here to strengthen the sector from these climate mitigation opportunities. Over to you, Malin, and apologize for these last minutes.
No worries at all. Thanks so much, both of you. You know that I'm a forester by training, and I have learned so much from your work in this chapter, and I would like to listen to this all day to learn even more, but we only have an hour. Okay, thanks so much. Now, next person will be another one of my colleagues, David Hebert-Coleman. David will share some relevant notes from his study on the enhanced nationally determined contributions.
Good morning, all. Yes, so the last slide by Ricard and Jacek were a very good segue into my little presentation. It's a very simple presentation because I have a very simple story to tell. So yes, I've been looking in the last, and you can go to the next slide, thank you. In the last couple of years, we were commissioned to have a look at the enhanced NDCs and try to get an idea of what was happening within countries in regard to water. So we were sort of asked to look at the water-related contents, and we actually looked at 114 enhanced NDCs with a focus on the so-called non-Annex 1 countries, and these are mainly low and middle income countries. Now, we didn't just look at water and sanitation, we looked at forestry, we looked at nature-based solutions, anything that had a lot of connections through to water, to try and get a feel for what were countries doing, what are they responding to, and trying to understand where we need to focus our efforts into the future. So, you know, as a whole, they definitely paid more attention to water-related activities in their first round of NDCs. Next slide, thanks. So some really simple numbers. So, and I have to be very careful as I go through these numbers because they refer to different parts of the water ecosystem, for want of a better word. So approximately 85% of these 114 NDCs included more measures across a wider range of water sectors and topics. So they actually paid more attention to water, not just in terms of drinking water, but across the board. Now, 80% of these enhanced NDCs paid attention to water supply and sanitation explicitly. Now that's a slightly different number to the other because the other number includes other factors around water. Now, of those, and this is where things start to go a bit awry, only 42% of those 114 actually had a reasonable amount of detail about their water priorities. And by that I mean that there were one or more measures and included some material around water, you know, why we needed to do this, whether impact or vulnerabilities. Now, there was a higher rate of inclusion found in the LAC region, the Latin America and Caribbean region, in the MENA region, and in Sub-Saharan Africa, compared to the overall numbers. Next one, please. Now, when we start to drill into the water mitigation aspect, predominantly around wastewater as indirect, as a direct form and other forms as indirect, it gets a bit worse, to be honest. So overall, including both adaptation and mitigation, 45% of the enhanced NDCs included measures around water supply and sanitation from a WASH perspective, with a focus on increasing coverage and access and helping to build resilience. 64% though, which is more positive, of the enhanced NDCs included measures around wastewater, including in both adaptation and mitigation sections. You know, for example, in the actual number of countries, so only 32% included wastewater measures within their mitigation sections, despite the very large potential, as sort of spoken about Ricard and Jacek, and by many of the other people who will be speaking after me. But beyond those direct wastewater aspects, very few recognise those indirect connections between water supply, such as those possibilities of water efficiency to reduce energy costs, or energy efficiency in respect of delivering water services that Ricard mentioned. So there's obviously a lot of opportunity. And I would also mention that whether it was adaptation or mitigation, there were very few measurable or quantifiable targets in this. And I think this is an important point that I'll touch on the next slide, thanks, a little bit later again, keeping an eye on time. So, and the reason why I say that is that most of the measures were quite generic. And I sort of group these into three types of measures. You know, there's this general intent, you know, to contribute to ensuring supply and availability of drinking water services. There is a policy intent behind some of them, like we're going to do this as part of our policy direction in the future, or then they might sort of talk about the inclusion of principles in future or planned assessments. You know, we're going to fund research into doing this water resources and water supply planning. But otherwise, there were no good baseline information. There was no idea of being able to evaluate the strength of the measurement. And this is actually a really scary point because, you know, it's very difficult to compare with other priorities within an NDC and being able to build the business case for why we need to invest in wastewater as a mitigation activity. Next slide, thanks. And I've got 30 seconds because I covered. In terms of WASH targets, SDG 6 was occasionally referred to, but there was almost no linkage made to the targets within the SDG 6. Very few targets overall, although there were some exceptions. For example, some did mention, you know, where our baseline is now, where we want to go to, and that helps you to build the business case that you can then sell to donors or to others to invest. And some did talk about how they were going to improve the efficiency of drinking water distribution, but there were about 4 of these out of 114. So lots of opportunity. Next slide, and hopefully it's the opportunities. So, you know, where are some of those opportunities for improvement? To build the business case, there needs to be inclusion of more connections to SDG 6 targets. There's a need to include baseline conditions and planned futures around WASH or wastewater and other things. Noting that Ricard mentioned that there were some difficulties in measurement. The wastewater information, measures and targets can definitely be improved. Some mentioned wastewater in the mitigation area, but put no detail about it. And overall increased recognition of water or energy efficiency in accessing, distributing and using water mitigation procedure are all areas for opportunity, and I will finish there. Sorry about the speed, but.
Thanks so much, David. Thank you so much. It's very interesting, your study on what countries aim to do with their climate work. Okay, first of all, there are some questions in the chat more general. Welcome all that has joined a little bit late. What we do with the chat is that it's lovely if you present yourself. It's nice to know where you're from, but it's also possible there to ask questions to the speakers. We will have a few minutes where we can raise questions. So if you have any questions, please add them in the chat. Okay, now we have two case studies to build further on what Ricard and Jacek and David has shared. First out, welcome Tallulah Lutkin from the Global Water Intelligence.
Yeah, hi everyone. My name's Tallulah. It's great to be here. Thank you so much to CW for setting up this webinar. So I'm Utility Performance Editor at Global Water Intelligence. And recently a lot of my focus has been on the carbon footprint of water and wastewater. So I'm excited to sort of briefly present some of the work that we've been doing in that space today. If we go to the next slide, I'll give you a quick overview of Global Water Intelligence for those of you who don't know us. We're first and foremost, we're a media organization. We report on news from the water sector worldwide, but we see ourselves as more than that. We see ourselves as the leading source of not just news, but also information, data, analysis, and we have a lot of opinions as well on the global water sector. We have a monthly magazine, we have a digital market research platform, we have a number of networking groups, including the leading utilities of the world, and we bring all those water networks together in our international conferences. The next one is the Global Water Summit in Berlin in May, so if you want to join us, we'd love to have you there. And so we've been seeing the carbon footprint of the water sector really coming to the fore. I was at COP27 last year in November, and it was really exciting to see, the water pavilion and see those conversations that were happening around water and climate. But we figured that there was still a lack of sort of data and consolidated information on this. So we have been doing a lot of work through our Water Without Carbon initiative. If we can go to the next slide. And what we're trying to do is consolidate all this information that we have and the research that we have onto this page, so you can access it through the link that's there. I'll also have a slide at the end with this QR code so you can access it as well. And the biggest part of our research on this has been our white paper that we've called Mapping Water's Carbon Footprint, where we present our data model of the total emissions of water and wastewater infrastructure worldwide. So it's available to download through that same link. So what I'm going to do is I'm just going to briefly share like a couple of the findings of the research, some of the highlights, but I really encourage you to go and download the full white paper and read it in your own time, because there's a lot of detail there. It's beautifully designed by a design team, and it's really, I think, quite unique. I mean, as far as we're aware, nobody's modeled the emissions of the sector quite as thoroughly as this. So it took a lot of work from our data team. I really encourage you to go check it out. But here are some highlights. So if we go to the next slide, and this is kind of an overview of our findings, and it kind of correlates with what Ricard was saying earlier, so I'm pretty glad that we're on the same track. So we estimate that water infrastructure generates 847 million tons of CO2 equivalent annually. This is about 1.8% of global emissions, and that's roughly the same as the aviation industry. So that kind of puts things into perspective a little bit there. If you look at methane emissions, that rises to almost 5% of global methane emissions, which again is really significant when you know that methane is really potent in the short term. So cutting methane emissions actually now is what can really quickly help alleviate some of the impacts of climate change that we're already seeing around the world. And so as you can see here, what I really want to highlight is that direct emissions of methane and nitrous oxide account for half of total emissions. So that's half of all these emissions are direct emissions. And all of those direct emissions come from wastewater and sanitation. And so there, if you look on the sort of second pie chart, you can see that wastewater and sanitation is 2/3 of total emissions from water and wastewater. So what we really wanted to do with this paper, and that's why we've called it Our Net Zero Future Hinges on Wastewater, is to really highlight the fact that that actually, yes, water and energy, that the water and energy nexus is important, but the wastewater issue with direct indirect emissions is often overlooked, and that's really what we need to focus on. So if we go to the next slide, I can show you that in a little bit more detail. So as I was saying, on the drinking water side, so the kind of blue on the left there, that's only energy. So all the emissions from drinking water basically come from energy, with some small exceptions. And yes, water is energy intensive, but we see that there are a lot of solutions that utilities are already implementing to become more energy efficient. So Rekha mentioned some of these earlier, optimizing all those energy intensive processes, optimizing pumping, optimizing aeration, harnessing digital. There's a lot of potential there to harness digital technologies for network optimization. And also on the wastewater side, producing renewable energy through biogas, and yeah, there's a lot of potential to produce green energy. So floating solar panels, big fan of those, wind farms on treatment plants. So there are all these great solutions, and so the utilities have the tools in their toolbox to kind of find the solutions for these. But on the other hand, the emissions from wastewater and on-site sanitation are only set to increase. I mean, we're seeing massive wastewater treatment build out in Asia and Latin America. There are regulations coming in to limit nutrient pollution, which means that nutrient removal processes will increase. And we know that those nutrient removal processes are the big trigger for nitrous oxide, which is already 30% of emissions from wastewater. So that's just only going to increase with more nutrient removal, and on-site sanitation, as we were mentioning as well, or non-sewered wastewater treatment, that's a third of emissions, and that's only going to increase as we continue sanitation build out to achieve SDG 6. So now there are solutions to mitigate these emissions. So utilities can harness that methane from sludge to produce green energy, which is kind of a win-win solution. Good aeration can limit nitrous oxide. And on the sanitation side, there's a kind of win-win there as well. So better management of the service chain, more frequent emptying of sanitation systems. That's something that can prevent methane buildup and also mitigate the emissions from sanitation. But there's so much more to be done, just even on the measuring, the modeling and the research on this. So it's really important for the sector to start monitoring this even before we can start mitigating it. And actually, we think that these numbers probably an underestimate. There's a lot of emissions that we couldn't include. So for example, there's a lack of data on methane from closed sewers. So like literally within closed sewers. We weren't able to include those, but from the conversations that we've been having, we think that's quite significant. And also on the on-site sanitation side, it's already a third of emissions, but we think that because the data is so patchy, this is probably an underestimate as well. So if you go to the next slide, I'll give you just another highlight from our paper, which is this kind of modeling that we're doing with the correlation between methane emissions and sanitation and achieving SDG 6. So we did a bit of modeling with our data that we had just to see the impact in terms of methane emissions. So currently, open defecation is considered to be zero carbon, but obviously, ending open defecation is absolutely essential for so many reasons: health, economic development, human dignity. It's just, there's no way we can continue with that, and it's the SDG 6 goal. And doing that, ending open defecation would mean a stronger reliance on on-site sanitation. And with current practices, that produces a lot of methane. So according to our models, if we continue current trends of build out, we're not going to achieve SDG 6 by 2030. 230 million people will still be practicing open defecation, and also methane emissions will increase by 100 tons of CO2. So if you look along the bottom, you can see the two scenarios of achieving SDG 6. The first one assumes that we achieve it by building out on-site sanitation, and this scenario will increase methane emissions by 50 tons of CO2e. And the second scenario assumes everyone will be connected to sewage systems. Now, we don't think this is achievable at all by 2030, but it's interesting to see that the resulting methane emissions would be less than half of the current volume. This doesn't include energy and nitrous oxide, so I want to just say that we're just talking about methane there, but it's really interesting to kind of see this correlation between sanitation and emissions. And actually, we think this is an opportunity particularly for finance, because actually, if we look at this correlation between sanitation and finance, sanitation and climate, that's something that can help get more money for sanitation, because there's this win-win solution in improving sanitation and also mitigating its emissions at the same time. So we really see that there's an opportunity there for sanitation to be a driver through climate finance, and to blend those two issues, to have the safe sanitation on the one side and the lower carbon emissions on the other. So that's it. I'm glad if we could just go to the next slide so people can get that QR code again. Those are the two highlights of the paper, but there's so much more in there that I could possibly have said in my sort of 8-minute presentation, and I really want to encourage you to go and download the white paper. There's a lot more information on there, green energy, on methane, nitrous oxide. So yeah, please go and download it, and yeah, thank you so much for your time.
Thank you so much, Talula. Super interesting. Okay, so next case study comes from Jordan. Welcome, Nadine Khantouz and Suhaib Ababne. You are both from the Sustainable Sludge Management Project.
Thank you, Malin. Hi, everyone. As Malin said, yes, we represent the GIZ project called Sustainable Sludge Management, and we'll dive in a little bit deep through the part where we're talking about resource recovery from the sanitation, let's say, perspective. Before going into the next slide, I just want to highlight a few points that the presentations earlier were talking about. Previous presentations were talking about GHG reductions from the sanitation perspective and focusing on resource recovery. We always think about wastewater treatment plants as clarifying and treating water that could be reused. And to a very large extent, the outputs of the treatment, such as sludge, is usually discarded and disposed of. If we focus on resource recovery and trying to, let's say, adopt a more circular economy, as well as focusing on impacts of climate change, we can find alternative solutions for this discarded considered waste. So if you can go to the next slide, please. This is maybe a little bit complex, but this is just a brief overview of some numbers of some European countries of statistics from 2020 talking about the different methods of sludge disposal. So if you can see, there are 4 main colors. One is based on disposal, general disposal. One is based on agricultural reuse. The other is composting, landfilling, and then incineration. As you can see, and based on the points that were discussed before, data is not readily available. So this is not conclusive for all countries, as well as not a lot of raw data information is available. But what could be considered here is that there is a number of measures that could be taken to reuse sewage sludge. The idea is to the idea of the project is to also consider where, and to focus more on where could the reuse happen. So next slide, please. Yeah. So this is also just an idea of some agricultural reuses in the Arab region. As you can see here, there are qualitative descriptions of where it could be used. Sewage sludge could be whenever it is further treated and meets a certain criteria of quality and, let's say, applied in a more managed and accurate way, could be reutilized in the agricultural sector on limited crops. And for some countries, they limit the reuse of it on raw vegetables and fruits. So the idea is here to see that there is no quantities or numbers there, because it is, let's say, a new version or a new sector to be studied. There are some advantages for reusing sludge, as it is, as it holds a lot of organic content that we can recover through different further treatment options. Next slide, please. In this slide, there should be another image. Okay. In this slide, it's just a summary of what are the types of sludge that could be reached if we implement further treatments. So as you can see in the first column, there's dried and pelleted sludge, which you can see in different forms. And then biochar. These, let's say, outcomes can be achieved when you apply advanced treatment options. If you can go to the, if you look at the second row, you can see where treated sewage sludge can support the agricultural sector. Mainly, utilizing treated sewage sludge could support in improving, let's say, the soil conditions, improve the water holding capacity within soil. Therefore, there is the use of water to irrigate some lands would be reduced, and therefore support in the climate action of certain countries, and to, let's say, utilize the resources available to them. In the last column, in the last row, we could see that even treated sewage sludge could be used as an alternative fuel source, therefore reducing the consumption of fossil fuel and thus reducing direct or indirect emissions, actually. So at this point, I would also transfer to my colleague Suhaib.
Thank you, Nadine. Thanks all. Next, please, slide. As were presented by my colleague Nadine, Citizen Projects was launched to find ecological and economical solution for sludge management in Jordan, instead of the current practices or non-environmental practices, whether it's the sludge currently sent to, let's say, damming area, non-engineering damming area, and or stockpiled inside the wastewater treatment plant. So through the Citizen Project, we will work on mainly on three main pillars. The first pillar is for identifying the technology. We will identify through this pillar the appropriate technology to upcycling the sludge and to produce new products. And the second pillar, we will work also on introducing the sludge products that will be produced by the technology to national or international markets to be used for agriculture and industrial purposes. And the third pillar is the legalizing the using the sludge products in the local market. When we talk about legalization process, we will mean that we will work on the regulations and standard levels. Next slide, please. So through Citizen Project, we started our work by preparing mapping study for the sludge. Through this mapping study, we identify the quality, the quantities, the current practices, the future plans of the more than 30 wastewater treatment plants in Jordan, and chose three or shortlist these 30 wastewater to 3 wastewater treatment plants to focus on them for upcoming activities through the project. After the mapping, we prepared the feasibility study on the 3 wastewater treatment plants that were chosen during the mapping assignment. Through the feasibility, we studied the feasibility of using pyrolysis technology to produce biochar, pelleting technology to produce sludge pellets, and due to its the nature of the sludge that is currently produced in Jordan, we need to install also a drying technology to dry the sludge for levels that is applicable to be used for the upcycling technologies. So we studied also the feasibility of using solar drying greenhouse technology in the wastewater treatment plants. And as a result of the feasibility, we chose to install solar drying greenhouse technology and pyrolysis and pelleting technology in a wastewater treatment plant called Mu'ta al-Mazar at the south of Jordan. Also, we prepared a market research study to identify the opportunities that is available in the national market to use the sludge for agriculture and industrial purposes. And we also studied the opportunities of exporting the biochar to the external markets. Currently, we are working to install and procure the equipment for the upcycling technology to be installed in the targeted wastewater treatment plant, and also we are working on comparing the sludge products quality with the international qualities as well as the standard regulations that to also make recommendations for the future activities on the standard and regulations in Jordan to be amended and to be legalize the utilization of the sludge in the agriculture and industrial purposes. And also we are planning to conduct an awareness raising campaign for our stakeholders to make the or to introduce the upcycling technologies and increase the capacity in sludge reuse activities. Next slide, please. Upon that, we are targeting in our project to treat 300 tons of dry sludge per annum in the targeted wastewater treatment plant as a targeted baseline for us. This is 300 wastewater, 300 tons of dry sludge produce around 1,273.9 ton of CO2 equivalent as a greenhouse gas emission for our baseline year in 2020. What we are aiming is to use 75% of this 300 tons as a dry sludge, as a pelleted sludge, for industrial sector to be used as energy carrier, for example, for cement factories, for power plants, generation factories. And we are planning to use 25% of these sludge as a biochar for pyrolysis technology to be used for agriculture purposes. And when we talk about agriculture purposes here, let's say that it's a restricted utilization. We are aiming to use the sludge for agriculture for restricted utilization, for example, to be used for forest areas and or to be used for fodder crops planting. Up on that,
please just note that time is up. I'm sorry, but
1 minute, please.
Yes. 30 seconds.
Finally, the benefit or the expected benefit from our activities through CISM project for the climate change is reducing 925.4 tons of the greenhouse gas emission from our baseline and reduce about 55% of the operational cost for the wastewater treatment plant that is currently paid on the sludge management right now. That's it, and thank you all for your listening.
Thanks so much, Suhaib, and thank you so much, Nadine, for giving us this case from Jordan. Okay, so let's now welcome all speakers back, and let's open the floor for questions from the audience. We have a few minutes for questions, and there has come in some questions. So let's see what we have. There is a question for David. Edith Kovacs asks, did you observe differences between regions when it comes to linkages with SDG 6?
So basically, no, there wasn't any specific region that stood out when it came to that. I would say, this is in general terms around WASH, or water and sanitation, not just in terms of mitigation. Overall, countries might mention SDG 6, or they might mention the SDGs as a whole, but there isn't very much in the way of specific engagement. With a rare, there are a few exceptions to that general rule, but that's about sort of 4 to 5 out of 114. So some would mention SDGs 6, but that would be better. Nothing further. So.
Okay, thanks. Yes. Then there is a question for Tallulah. Lindsay Higgins asks, is there a startup presence at the Global Water Summit?
So yeah, there can be. We actually often host a session in collaboration with our utilities so we usually call it 30 technologies, and I think that the one for this year is going to be 30 technologies for water and climate, so it's actually quite relevant. So in this session, technology providers can come and pitch their new tech to utilities, and sometimes we have startups who come and do that. So yeah, it can also be tech, and I think there are some sort of service providers, or more service type pitches as well. But yeah, there can be, yeah, absolutely.
Thanks. Let's see here what we have. We have a question from Dr. Kudirat and it's directed to David, but I see that Ricard wrote an answer, so maybe you can give a brief answer. What method can be used in wastewater treatment where there is poor sanitation habit?
Yeah, no, just to say that if we are talking about decentralized sanitations, maybe there are a few options, particularly to reduce methane emissions, trying, of course, to improve the composting practices of human waste, and then, of course, try to enhance the capture of this methane by household biodigesters. That would be one option. David also pointed out about the need of focusing on the whole sanitation chain. It's not only the issue of the containment, the latrines, but also the collection and the treatment of this fecal sludge. So here there are huge improvements. But I would like also to hand over to Jacek, because if we are talking about centralized treatments, probably he's in a better position maybe to provide what are the best options here for this kind of treatment possibilities. So over to you, Jacek, maybe.
Yeah, I think, yeah, just maybe one comment concerning those methods. I think that a natural-based solution could be, an option for the areas with poor sanitation, and because natural-based methods are relatively well, they are cheaper than the methods I presented in my presentation, and the approach is completely different in terms of processes. Also, they are more similar to the processes that are, and the speed is similar to the processes which occur in the nature. So I think that this would be the option, which is as I mentioned, different in comparison with those developed in developed countries.
Thanks so much, Jacek. We also have a question for the Jordan team. Amazing work, Edith says, and is wondering about your approach to awareness raising, since this is a complex issue and it's involved a shift in mindset.
Yes, thank you, Malin. And I mean, it's a very relevant question. Of course, the reutilization of biosolids, treated biosolids, is a big shift. The awareness raising starts from sharing experiences from different countries around the world that are similar to the conditions of Jordan in terms of their wastewater systems and their, let's say, industries or different sectors. So the awareness sessions, we're starting to introduce it from a regulation point of view. What are the quality limits that are being, let's say, complied with in different countries? How could they be reflected in the Jordanian context? And it's a long journey, it's a long process, but this is where at least the start is to present and to make either the end user or the, let's say, the decision makers and policy makers aware of the benefits, as well as the right management approaches that need to be dealt with or handled when utilizing sludge.
Okay, thanks so much, Nadine. The Q&A session or section of this session is coming to an end, but before we close, I would like to welcome Jose Gesti from Sanitation and Water for All. Jose, you are about to give some closing remarks, but before that, do you have a question to someone in the panel?
Thank you, Marlena. It's a great pleasure from our side as the Secretariat of Sanitation and Water for All to be part of this discussion, and we have seen the making of this report, which we really appreciate. Yes, I do have. Maybe it's not just a question, but it's more if I really think, that we were just talking right now about awareness raising and changing mind when it comes to high-level policy makers, and how can we make this shift in their mind so that we start to see more what David has been analyzing policy, climate policy, and I start to see water and sanitation reflected in mitigation, I think there is something which can really help us make this shift, which is comparing ourselves with the transportation sector. And just to understand what we're talking about, right? I think Tallulah has, our colleague from the Global Water Intel has made a quick connection, like comparing these. I really think this can help us. And I could just invite Tallulah to refresh our mind, as to how do we compare with the transportation sector.
Yeah, exactly. It's a really great point. That's what we did when we were looking at this number, like, okay, what's the comparison point here? And 2%, water and wastewater is 2%, and the aviation industry is 2%. So that's just like, yeah, it's just that can sit with people. Yeah, you're quite right.
No, thanks for that, Tallulah. And I think if one of the things that we leave this session today is with this comparison and how close we are to the transportation sector that we know receives so much attention when it comes to high-level policy, climate policy, and the reduction of emissions. I mean, we are there. We are at the same level as the aviation sector. This is a huge thing that we need to remember when we pass our messages. But yeah, I think we are getting towards the end, right? And Marlene, probably you will appreciate if I jump
please
into.
go ahead with the closing
Yes.
remarks. Thank you.
Thanks. No, and again, thanks for inviting us. I mean, let's try to wrap up a little bit things and put things into a higher level kind of concluding remarks at this point in the webinar. And then let's come back to the fact that the Paris Agreement that countries have agreed a couple of years ago, right, is setting us to not more than 1.5 degrees increase in temperature by the end of the century. So it's between 1.5 and 2 degrees. That the Paris Agreement is setting us, so we should not increase the temperature beyond that. The Intergovernmental Panel on Climate Change is reminding us over the last reporting period that we are currently not on track to meet the 1.5 degrees scenario by the end of the century. The Intergovernmental Panel on Climate Change is also telling us that the relationship between climate change mitigation measures and water is a reciprocal one. And this means that the measures that are introduced to reduce greenhouse gases emissions have a direct implication for water resource use and management. But at the same time, what we're discussing today is that water extraction and water management measures have an important impact, as we are making the connections now, on carbon emissions due to the energy intensity of wastewater, water and wastewater treatment and the distribution systems. So as we have seen today, good work is already being done by water and sanitation service provider in many countries, and that's to reduce greenhouse gases emissions. However, we see as well that we have increasing evidence suggesting that unsustainable water and wastewater management is indeed a major source of greenhouse gases emissions. Much more can be done and much more needs to be done by those who have the great responsibility for the management of water resources at the local, regional, and national level. The role that governments and other actors, including the private sector, must play in water stewardship to achieve a sustainable and low carbon future is acknowledged, as we've seen in the SDGs and in the nationally determined contributions. However, we see that this awareness is still incomplete, and few institutions and actors which are responsible for updating and implementing national determined contributions, but also national climate change strategies, haven't at the moment fully taken water and sanitation related mitigation issues into account. At the global level, we see that the United Nations-led Race Zero campaign has set a target to fully decarbonize water and wastewater services in 20 countries by 2030 and around the globe by 2050. We also see how the Marrakesh Partnership Climate Action Pathway is aiming for the water sector to be a net positive source of renewable energy by 2040. So these are huge targets. We have a lot of evidence now. We have the important information that the report that is being presented today and this particular chapter on water and sanitation is giving us. We have a lot of information on what the wash sector can do. And then my final word is that it is time now that the world takes up the role of water and sanitation services in achieving the Paris Agreement goals. So let's join our hands and let's move forward. Let's build that business case that David was calling for, and let's start getting this action into policies and strategies in our day-to-day work. Back to you, Malin. Thank you.
Thanks so very much, Jose. And yeah, let's. I think that your and Talula's point on comparing it with aviation is a great way to communicate this message strongly over the world. With that, thanks so much to all speakers for providing all your interesting insights here. Also, a great thanks to my colleague Malin Wennerholm, who is working behind the scenes with the whole webinar series. I really hope and believe that this webinar has helped improving the representation of WASH in the climate policy debate. And I hope that we can feed these messages into the upcoming UN Water Conference in New York in March. Thanks all for listening in, and thanks for all your great questions. And I hope to see you next time when we will focus on climate mitigation in energy systems. And then we will have a big focus on bioenergy. So thanks, that's all for this time. Have a lovely day.
Thank you. Bye.
Bye, thank you.